Okay, so what do we got? How am I going to do this? If I want to write, what's that arrow mean? Goes on forever, right? So if I want to represent this set of all the shaded region up there on the x-axis, let's say, on the real lines, how am I going to do that? X is what? Okay, I'm hearing greater than, okay? Greater than or equal to 4, perfect, okay? So how does that different from something like, what if I instead asked you this? What if we had, oops. How would I graph that one? Or how would I write that inequality? X is less than, do I put the equal to?
No.
Okay, how come? Say it again. Okay, because this is an open endpoint, right? If it's an open circle, that means it's just the boundary, but it doesn't include the point, right? Okay, you get that? How do you remember that? Well, it takes more ink to fill in the dot, and it takes more ink to write the line, right? So more ink goes with more ink, okay? All right. What's that going to be? Top one. Somebody do those two on your own real quick. Okay, what do we think here? Let's see. Connor, what'd you get for the top one?
Top one.
X is
less than -2.
less than -2. Okay, good. Savari, what'd you get for this one? Okay, somebody help Ryder.
X equals 2 and is greater than 2.
Okay, so that's the right idea. Equals, and how do we say that though? Greater than or equal to. Good. So X is greater than or equal to -2. Good. Okay? Good, good. All right, so we got the idea of how to kind of correlate the graphs with the inequalities. Right. Not a big deal. Next step, solving inequalities. You know, we've solved equations, now we're solving inequalities. How is it different? Almost the same. It's almost exactly the same. We'll look at a few examples to kind of distinguish. There's a handful of cases, just like really not very many, where it's different at all from what you've done in the past, which is solving equations. So we're still going to reverse PEMDAS to isolate. That's all we're trying to do is isolate the variable on one side of the inequality this time instead of an equation, right? So what would the steps be to get the x by itself here? What do you think? Ian, what are going to be the steps to get that x by itself? First, I add 1. Very good. And then I... Does that make sense? So our goal is to get the x by itself. So you chase the 1 away to the other side. Now you got to get rid of the 4 by division. Make sense? Add 1, divide by 4. Nothing changed. Same as before. If we add 1, we get what, 16 on that side? We divide by 4. We get x is less than or equal to 4 is our answer. No biggie, right? Easy. There's no difference in what you've been doing. Okay, how about this guy? Take a second, think about that. Okay. Jade, what do you think? Got to get the x by itself. What do you do first? Okay, first though, you gotta be real careful about the, we're gonna, remember, we're doing order of operation. Huh,
I'll text her.
yeah. So to isolate, we got a reverse order of operations. So what do we have to do first? Okay, subtract 2, right? So 8, right?
Yeah.
Okay, now what? Okay, so you could make this 2 steps. You could multiply both sides by 5 and then divide by 8, or let's think about it differently. We're just multiplying x by a fraction 8/5, right? So now, how do we typically, we already undid the addition by subtracting, right? We undid the addition by subtracting. Here, we're gonna undo, we're multiplying x by 8/5, right? How do we typically undo that? Okay, so typically we undo multiplication by dividing, and that's correct, right? We're gonna divide both sides by 8/5, but that doesn't sound good, right? Dividing by a fraction is harder than multiplying by a fraction. When we're dividing both sides by a fraction, what do we always do instead? Multiply by the reciprocal, right? So if we're trying to get rid of multiplying by 8/5, we're just gonna multiply each side by 5/8. Right? So the 5's cancel, the 8 cancels, that's good. And we just get x on this side. What about over here? Yeah, look, the 8's cancel and I just get 5/1. Okay. No different though than the last couple assignments, right? Same as before. I mean, going back to like solving multi-step equations, right? Same stuff. Okay. This time we gotta be a little careful. Here's where all of a sudden things get slightly different. Okay, what are the 2 steps in order here? What do we do first? Add 2. So we add 2 and then divide by -4. Sounds easy. Let's go through those steps. So we add 2. What's that, -2? You said divide by -4, right? Okay, so far so good. That cancels the -4's, right? And we get an x on this side. On this side, -2 over -4 is +1/2. What's different? Okay, good, good. Here's the difference. This is the only thing at this point you gotta really be aware of. When you have an inequality instead of an equation, if you multiply or divide both sides by a negative, you gotta reverse the inequality. And so notice I made the negative sign red there. That's because it's a red flag. We know that when I've got dividing by a negative, I've gotta reverse that around. So my answer looks like that. Okay? Does that make sense? Okay? Okay. I'm just going to throw in just one little bit here. So we were dealing with simple inequalities. Now, what if we want to join 2 inequalities together? So this, we're making the jump. I'm just going to introduce this for today. In the first assignment, you can start on the second one if you want to. This is section 1.7. The first assignment is just purely simple inequalities. The second one is compound inequalities. So we'll finish this up tomorrow, but let's just start thinking about it today a little bit. So, compound compound inequality means we're gonna have two conditions on this now. What if we wanna say x is greater than 3 and less than or equal to 7? How could I do that? I mean, if I just write that out the same way that the sentence is written, I could say x is greater than 3 and our symbol for and is the caret, right, upside down V, and x is less than or equal to 7. Thanks. When we write out an and compound inequality, though, there's a better way to do it. Think about what numbers would be included in that set. What numbers are greater than 3 and less than or equal to 7? Give me an example. Say it again. 4, 5, 6 would be examples of integers, right? And 7, I guess, too, right? 4.5, 5.5, etc., right? What are examples that don't work, that don't fit in that set? 10, 2, 1, etc. Okay. So wouldn't it make more sense if we're talking about an and inequality? Now, this only works for and inequalities. Wouldn't it make more sense to put the smaller of the two numbers on the left and the bigger number on the right? And I'm going to put the x in the middle, right? And now I could say x is greater than 3 and less than or equal to 7, and that visually makes pretty good sense, doesn't it? What if I were to graph this on a number line? What would it look like? So there's the x-axis. What are the important numbers here? I guess we've got 3 and 7. How would I do this? How would I shade? What part would I shade in here? What region? Okay, so I'm going to go, that's going to be the left boundary, isn't it? What kind of circle? Open, okay, because I don't have an equal sign. Here's the right boundary. Closed, right? And everything in between. Does that make sense? Okay. Okay, so the way we would read this then, when we write an and inequality like this, so and inequalities, both of them get jammed up into one big triple inequality, right? Variable goes in the middle, lower limit on the left, upper limit on the right. And the way we would say this, we always start in the middle and say what's going on with x. X is greater than 3 and less than or equal to 7. And that makes sense. We're saying it's pinched between this lower limit and this upper limit, right? Including the upper limit, right? Okay? What about one of these? X is less than 3 or greater than or equal to 7. How do we write that? So now we've got x is less than 3 or, and our symbol for or is like a V, okay? Or x is greater than or equal to 7. Can I combine those together? Well, let's look at the graph of this. And you tell me. If I graph this on the x-axis, the important numbers, once again, are 3 and 7, right? What about this? X is less than 3. What does that look like? If I were to graph that. Okay, so that part's going to be, everybody agree, open circle? Which way am I shading? Left. How about up here? X is greater than or equal to 7. So solid or closed?
Solid.
Solid. Which way am I shading here?
Right.
To the right. Okay, see the difference? An and statement has to be one single interval. It can't be two, right? An and wouldn't make sense here, would it? What if I tried to make this an and statement? If I said x is less than 3 and greater than or equal to 7, name a number that does that. There isn't one. You can't do both. If it's an and statement, it's more particular. It means all the things have to be true at the same time, right? Raise your hand if you are taller than 5'10", if your height is greater than 5'10", and less than 6'1". Raise your hand. Okay, so we got a few people whose height happens to fall between those intervals, right? Okay, raise your hand if your height is greater than 5'10" or less than 6'1". I'll say it again. Raise your hand if your height is greater than 5'10" or less than 6'1". I'll say it again. Raise your hand if your height is greater than 5'10" or less than 6'1". Okay, so should anybody's hand be down? No, it doesn't matter though. So think about this. Okay, raise your hand if you're greater than 5'10". Raise your hand up. Put it real high. Okay, put your hand down. Raise your hand if your height is less than 6'1". Okay, did all of you raise your hand at least once? Yeah. So now if I add an or symbol, your hand goes up, right? And or means one or the other. Do you get my point? Okay. So an or means it's less strict, right? It just means this or that. Any one of them works, bingo, that counts, right? So an or, if I graph an or statement, it's fine to have multiple intervals, more than one. Because now all this means, like let's say an ant has to be standing, an ant's walking along the x-axis, and he has to be standing in this set. Well, he could be right there, or he could be over here, and it'd be fine. He just can't be in the middle, right? Up here, if the ant has to be greater than 3 and less than or equal to 7, well, he's limited to only that finite region where both of those are true at the same time, right? So if I were to, well, we'll look at just a couple of these. And then I'll add just a little bit tomorrow. So tomorrow will be really small. So let's look at this. This is an or statement, right? Everybody see that this is the or symbol. So read that as or. If I'm solving a compound inequality that's an or statement, remember, those are completely separate intervals. So I deal with them one at a time, right? That's all it is just two problems in one, period. So for this one, what would I do? Let me rewrite this. So I can look at this inequality and just focus on that one and finish it, just solve for x. What would my steps be there? First what would I do? I'm solving the blue one for x, trying to isolate x. Add 2. Okay, so I add 2. Negative 15? Now what? Okay, good. We got to get rid of multiplying by 5/4, so we multiply by the reciprocal. Good. So I get x is less than or equal to, what about over here? Good, so I can reduce, right? Negative 15 over 5 reduces to negative 3 over 1. So I just get negative 12. Everybody agree? So that's part of it. There's part of it. That's part of my answer. What about the red part? What do I do over here? Add 7. Or subtract 7, right? So I get 9/4 x is greater than, was it 54? Now what? Reciprocal. And then let's see, 54 over 9 reduces to 6 over 1, so I just get 24. And what's the symbol that joins them? Or, right, so so this is an or statement, right? So if I wanted to graph that, what are the important numbers here? Negative 12 and positive 24. What's the blue graph look like? Closed circle to the left. Red graph, open circle to the right. There you go. Right? So if it's an or inequality, we just solve them both. Right? What if it's an and inequality? Something like that. These are actually, I think these are easier. They're quicker. Okay, think about that for a sec. How do I say that, first of all? What do you think? Walker, how do I say that? If you wanted to read that to somebody, read that expression, that compound inequality, you remember? It's tricky. You start in the middle. What do you think?
4x plus 3
Good. Is
less than or equal to
and
greater than or equal to.
very good. The only thing I'd switch is, just because we want to think about this like a number line, let's always kind of start with the lower limit, but otherwise, that's fine. Start in the middle. 4x plus 2 is greater than or equal to negative 10 and less than or equal to 26, so it's pinched in between those values, okay? All right, so what do you suppose we do to solve this? We're trying to isolate x. Okay, so we're focusing on the middle, aren't we? Because that's where the x is. That's what I'm trying to isolate. What are the steps going to be to get the x by itself? Subtract 2 and then divide by 4. The only difference is we're doing it to all three parts at the same time. That's it. So it's actually easier to get it done in one process instead of two. So if I subtract 2 from everything, we get 4x, negative 12, 24, and then we just bring down our inequalities, right? You told me divide by 4. And so what do we get then? So we end up with negative 12 over 4 is negative 3. X and 6. So if I were to graph that one, what are the important numbers?
Negative 3.
And what do I do?
Closed.
Okay, closed endpoints for both of them. And that's my lower boundary, that's my upper boundary. I'm pinched in between those two, right? So that's it. That's an and statement, right? Okay. One interval that's bounded on both ends is and. Okay. Two intervals, separate intervals, is or. It's like the oars on a boat. If a boat's coming right at you and the oars are doing this, right? The arrows are like the oars. Okay, we good? Okay, get going. That'll get you into those next assignments. There's just one more tiny bit to go through tomorrow, and we're done with 1-7. Yes.